Let's talk about balancing equations and solve number 4 on your balancing worksheet number 2, which is the blue sheet. When we balance equations, what we want to do is we want to make sure that we get an equal number of atoms on each side. So what I've done so far here is set up a balancing problem. I always start with my chart by drawing a line right down the middle, and then I figure out the elements that are going to need to be balanced. Now in the past, some of you may have said SO4 by itself, right here, needs to be just one polyatomic ion. However, in balancing, we take each element as its own. So when we balance, we count how many numbers of atoms are on the reactant side versus the product side. So in this equation, we are reacting zinc with hydrogen sulfate, and it produces zinc sulfate plus hydrogen gas. So let's count our atoms. We have 1 zinc, 2 hydrogens, 1 sulfur, and 4 oxygens. On the other side, 1 zinc, 2 hydrogens, 1 sulfur, and 4 oxygens. So now, we need to try to solve the problem. Well, as you can see, everything is already balanced. Zinc equals zinc, hydrogen equals hydrogen, sulfur equals sulfur, and oxygen equals oxygen. So in this situation, we don't have to do anything. We can just simply write the equation is balanced. However, we do want to make a note of what type of equation this is. And this reaction is a single displacement. We will learn more about reaction types in upcoming videos. Let's take a look at another balancing equation example. I know a lot of you are struggling a little bit from the top here about how to balance these problems. I'm going to try to give you another example to ease your pain. You'll notice here that what I'm going to do is once again break down the elements. I have a carbon, hydrogen, oxygen, all on what we call the reactant side. This would be like if you were in the lab and you go ahead and you mixed 2 chemicals I gave you. Okay? And if you reacted these two, what you would produce is 1 chemical over on the side called the product. And over here we obviously also have carbon, hydrogen, and oxygen. So now we're just going to count atoms. In this case, we see that we have 4 carbons. We have 6 carbons in this molecule, but we also have 2 over here. So that gives us 8. We have 3 oxygens here, plus 1 more over there, so we have 4. Let's count carbons over here. 2, 4 hydrogens, and 2 oxygens. If you're struggling to understand how I got those numbers, take a second here to pause the program and try to add up the numbers. Next, I'm going to look and I'm going to compare. Carbon, I got 2 versus 4. Hydrogen, I've got 4 versus 8. And oxygen, I have 2 versus 4. So unfortunately in this case, none of my atoms match up. So according to Newton, I would be completely wrong at this point. So what I'm going to do is I'm just going to pick an element to go ahead and start balancing. In this case, I'm going to pick carbon. I'm just going to start at the top. So since I know that there's 4 on this side, I'm going to go ahead and start on the product side. And I can only change the number in front. I can't put numbers in the middle of a molecule. So I'm going to go ahead and put a 2, because I know a 2 times 2 carbons will give me 4. So when I do that, I know I have 4 carbons. However, this 2 that I just made also is going to change my hydrogens. Since I have 4 hydrogens and I'm times 2, now I have 8 hydrogens. Since I had 2 oxygens, 2 times 2 gives me 4 oxygens. Surprisingly, it was that simple. Adding a 2, which is a coefficient, that is any number that is a whole number, meaning there's not a decimal, I can put in any of these blanks. So since I didn't put a blank in here, I don't write 0. All right, we just assume that the answer then would be 1. However, just like in ionic bonding, we don't need to write 1s. So our final answer would just simply be what is written at the top. This would be the final chemical equation. C4H6O3 plus H2O yields 2C2H2, H4O2. Okay. If I had to say this in chemical terms, I'd say tetracarbon, hexahydrogen, trioxide plus dihydrogen oxide yields 2-dicarbon tetrahydrogen dioxide. These are obviously all covalent because there's no metals present. When you're looking at balancing equations, it's important to make sure that you understand that at the end of the day, all that matters is that the carbon on the reactant side, the product side, the hydrogen on the reactant, the product, and the oxygens on the reactant and product line up. If you can do that, you can solve any chemical balancing problem. They will get more difficult, but with some patience and some practice, you'll get there.